Hi, I'm Ms. Fung. Today we're going to look at exact values. We're going to look at sine, cos, tan, and we're going to memorize what they are at different angles. So have a piece of paper and a pen ready for you to scribble a lot and try to write down what we're doing after each section, and then look up to see if the numbers in the pictures matches. Here we have the unit circle. Recall that the radius of the unit circle is 1, and as we go here we are at 0. So sine of 0 is, well, sine is the y value, so it is 0, and the cos of 0, well, cos is the x value, so the x value is 1. And tan is sine over cos, so I've conveniently put sine, cos, and then tan underneath there, so I can look at the value 0 over 1 is just 0. So your first task now is to write sine 0, cos 0, tan 0, and without looking, see if you can recall that sine 0 is 0, cos 0 is 1, and tan 0 is 0. Next up, we go to this point up here, which is 90 degrees. And the sine at 90 is our y value, which is 1, and the cos over here is our x value is 0. Well, the tan is the sine over cos, 1 over 0, which is, well, dividing by 0 it is undefined. So again, on a piece of paper write sine 90, cos 90, and tan 90, and see if you can record it 1, 0, and undefined. The way I remember it is I picture the unit circle and I think of my x, y, and then sine over cos for tan. Next up, we're going to draw or visualize this equilateral triangle. If each of these sides is 2, 2, 2, then the angles will be 60, 60, 60. And if I drew a line right in the middle, this side here would be how long? If this whole thing is 2, then this side here would be 1. And we notice that if this is 1, this is 2, Pythagoras theorem, this would be the square root of the hypotenuse squared minus that side, or in other words 2 squared minus 1, so it's the square root of 4 minus 1, which is the square root of 3. So this side would be 3, and because this is 60 degrees and we chop the triangle in half, that is 30. So before you continue with the next section, I want you to memorize this triangle: 1, 2, root 3, 60, 30. 1, 2, root 3, 60, 30. And on a piece of paper, I want you to draw this out without looking, and then look up and see what values matches what is missing, and then memorize that missing value, and then do it again until you look up and it looks exactly the same, and then do it one more time to make sure that it sticks. Okay, now that we memorize this, what do we do? Well, we can figure out 60 and 30 degrees. So let's add that to our table of values that we're going to memorize. So 30 degrees. 30 degrees means that if we look over this angle, then that's the adjacent and that is the opposite. And sine is opposite over hypotenuse. So 1 over 2. Whereas cos is adjacent over hypotenuse. So root 3 over 2. And then tan, well, it's sine over cos. A half over root 3 over 2 is 1 over root 3, because the 2 cancels out. Or opposite of adjacent, 1 over the root 3. For 60 degrees, we go opposite and adjacent. So now we have sine is root 3 over 2, opposite over hypotenuse. Cos is 1 over 2, and again tan is opposite of adjacent, root 3 over 1, which is root 3. So you can see why it's useful to memorize this triangle, because if you memorize this triangle, you can figure out what sine, cos, tan of 60 and 30 are pretty quickly. Let's do one more triangle. This time we have 1, 1. And if this is 1 and this is 1, then the hypotenuse will be square root of that plus that, or in other words, square root of 2. And because this is these two sides are the same, that's 90, and that's 90 divided by 2, the angles, which are 45 each. So memorize this: 1, 1, root 2, 45, 45. 1, 1, root 2, 45, 45. So without looking, draw this triangle on your book as much as you can, as accurately as you can. Look up and then see if you're missing any values, and then do it again until you look up and your triangle is exactly the same as that in terms of values. Okay, so now we fill in the 45 slot over there. opposite of a hypotenuse, doesn't matter which side you look from, it's 1 over root 2. Adjacent of a hypotenuse is also 1 over root 2, and tan is 1 over 1, or in other words, 1. To memorize this, it looks a little bit scary, but there's a trick here. If I rationalize the denominator, so multiplying by root 2 over 2 for these ones, I end up with root 2 over 2. And then we can see a pattern. See, sine of 30, 45, 60 is 1 root 2 root 3 over 2. And cos, well, they're complementary angles, so it's root 3, root 2, and 1. The other way around. And then tan is just 1 over them. So 1 over root 3, 1, and root 3. So if you look at drawing a table, you could quickly fill it in by writing 1 root 2 root 3 over 2's, root 3 root 2 and 1 over 2's, and 1 over root 3, 1 and root 3. Make sure your angles are from smallest to largest. Okay, so now that you have had a look at these two triangles, also consider in radians. So we know this is 60 and that's 30. 60 is 180 divided by 3. So in other words, 60 is pi over 3. And 30 is 180 divided by 6, or in other words, pi over 6. And remember, this is a bigger fraction than that. This is the bigger angle. Pi on 3 is twice as big as pi on 6. And over here we have 45 degrees. 45 is a quarter of pi, or a quarter of 180. So now we can add these. So we can use radians or degrees, and our exact values are going to be the same. So this should be memorized by the end of this video, or memorize the triangles. I still use the triangles because I find that it's a bit tedious to write all this out. Example 1, evaluate without using a calculator. Sine 90. Well, when I think of 90, I think of the unit circle, and 90 is up here. And when I think of sine, I'm thinking of the y value. So the y value there is 1. Cos pi. When I think of cos pi, I think of the unit circle. I'm all the way here, and cos is my x value. The x value is -1. Tan 180. 180 is also here. Well, I know my sine here, or my y value is 0. So 0 over -1, the cos, so sine over cos is tan, so it's just 0. Or you can use the table over here. So tan 180, oh, it's not there, sorry. Sine 90 would be here, 1. What about if I have sine 45? So this is not exactly on the axis of the unit circle, so we're using one of the two triangles. Which triangle are we going to use? We're going to not use that one, the one that says 1, 1, root 2. So 45 is like my pi on 4. So sine of that would be 1 over root 2. So when I'm doing this with pen and paper, I actually scribble these two triangles and the unit circle really quickly. But obviously I only scribble the one that I need. So in this case, I would scribble that one down. Cos pi on 3 would mean we're using this triangle. So pi on 3 would mean we're looking at here, and cos would be adjacent over hypotenuse, 1 over 2. And tan 60 would mean we're using this triangle over here. 60 is pi on 3, or the bigger angle down here. So tan would be opposite over adjacent, which is root 3. So you can see that you can use this, or you can use this. So tan 60 would be over there. Example 3, state the equivalent angle and which of sine cos tan is positive in that quadrant. So 150, where are we? 150 would mean we are 180. 150 would be somewhere here. It would be 180 minus 30 degrees. So our equivalent angle is 30 degrees, and all station to Caulfield. So we're in the second quadrant, so sine is positive in that quadrant. And then 240, where's 240? 180 plus 60 is 240. So we're in the third quadrant, ASTC. So tan is positive in this quadrant, and the equivalent angle is 60 degrees. 690, that is 360. 360 plus 360 is 720. Oh, that's too much. We have to go back a bit. 720 minus 30 degrees. So our equivalent angle is 30 degrees. And we're in the fourth quadrant, which means ASTC, cos is positive over there. minus 30, this is exactly the same as 690 in terms of value, because we're in the fourth quadrant. The equivalent angle is 30 as well, and the fourth quadrant means cos is positive. Negative 225. So remember, negative means we're going clockwise, and positive means we're going anti-clockwise. So negative 225, well, this is negative 180. So it's negative 180 and then another negative 45. So our equivalent angle is 45, and we're in the second quadrant. Oh, I'm missing a line, sorry about that. And the second quadrant, AS, sine is positive. The last one, minus 120. Minus 120, we are in this quadrant over here because it's minus 180, and then we're going anti-clockwise, so plus. So minus 180 plus 60. So our equivalent angle is 60, and ASTC, it is tan that is positive in that quadrant. So have a practice of this, because we're going to use this skill in the next example. Example 4. Let's have a look at sine 150. So where are we on the unit circle for sine 150? We are 180 minus 30, so the equivalent angle is 180 minus 30. So the equivalent angle is 30. And AS, so sine is positive. So always think about where are we, find the equivalent angle, and state whether it's positive or negative in that quadrant. Sine is positive over there. Now sine 30, well, we know what sine 30 is. We're going to use one of our triangles, that one over there. Sine is opposite over hypotenuse, so a half. Let's do tan of 660. So tan of 660, well, 660 is 360, 720, 720 minus 60. So we're in the fourth quadrant, ASTC. So tan is not positive there. Tan is going to be negative, and our equivalent angle is 60 degrees. So negative tan 60. So we still use this triangle. You can see why it's so useful to memorize this. Tan is opposite of adjacent, so we have negative root 3. So the negative comes from which quadrant we are in. So before we do the last question here, let's recap. So you try to figure out which quadrant you're in, so you get the equivalent angle. Then you figure out whether you're positive or negative, so sine, whether it's positive or negative, or tan, whether you're positive or negative. And then you find the value from using your triangles. So cos minus 45. Minus 45 means we're going this way and we'll land somewhere in here. So that's the same as ASTC. C is positive there, so it's the same as cos 45. 45 means we need the other triangle, and cos is 1 over root 2. Okay, thank you for watching, and have a practice. You might want to redo these questions, and I'll see you next time. Bye!